Okay, this video is going to go through the basics of electrolysis. So if you want to really get a good understanding of those key ideas, that would be great. And then the other videos on the channel, you can look at applying those ideas to different situations. So we're going to start off here. Remember that electrolysis is the breaking down of substances into simpler materials using a DC, direct current electrical supply. And to do this, we have to have an electrolyte, because we know that ionic compounds have this lattice arrangement, and this means the ions are not free to move, and these ions have to be free in order for electrolysis to work. So electrolyte literally means loose ions, loose charge. Okay, so linked to this, once we've got our electrolyte formed, as we said, we have to use a DC electrical supply in order to break down the materials into simpler substances. The chemistry word for breaking down those materials is decompose. They have to decompose those materials, and we have to form simpler substances during the electrolysis process. For example, if we had sodium chloride as our ionic compound, we would form from that sodium and we would form chlorine gas. Two simpler substances would be formed from my ionic compound. So how do we do this? How do we go about this? Well, electrolytes, we said, have to come from an ionic compound. So we take an ionic compound. This can be in one of two states for these ions to be loose. We could have it in a molten state. So molten state would mean we just take this ionic compound, heat it up, and the bonds start to break, those attractions start to break, allowing the ions to move. Second option we could do is we form a solution, and the solution means that we have dissolved it in water. And if we do that, the electric attractions start to break down, and that allows the ions the ability to move. So these two situations both lead to the same outcomes. Ions are free to move, so these ions are now free to move. The ions, let's classify the ions to help us understand this. So the ions we're going to have cations, which are the positive ions. Remember how to remember that? Cations, cats, and positive, I love them. And we have also the anions, which are the negative ions. There's the N minus, it's a negative ion. The cations, they're going to form at the cathode, so they're going to be attracted, migrate to the cathode, which is negatively charged, and the anions are going to go to the anode, which is positively charged. So if we had a little picture underneath to show this, there's my electrode, there's my second electrode. We'll make this one the cathode, keep it on this side. We'll make this one the anode on this side. And within here, if I had my positive ions and my negative ions, my cations are going to go this way, migrate this way. My anions are going to migrate that way. And once they're here, reactions take place that allow these to become simpler substances. The next video we'll explain that. It's worth a good look. Just remind it to yourself, these electrodes are made from graphite. And you should know that graphite is very important because, one, it is inert, so it's not going to react, it's not going to take part in the reaction. And the second reason is it conducts electricity, because, linking it to bonding, the carbon atoms in this graphite have 3 covalent bonds, therefore they've got 1 electron spare that becomes a delocalized electron, which means it can conduct. So as I said, hopefully that's helped with the basics. Have a watch of the other videos where it explains these principles with some examples, and hope that will help with your understanding of it.